Alright, so we just finished doing back references for now. So let's move on to another token. So the next one I want to do is assertions, and these start to get interesting, and this is going to lead us back into why we have that weird key thing for capture groups. So recall, assertions are things like this. I'm sorry, that's atomic. If I look ahead and see the string ABC, then I want to consume whatever. Doesn't matter. 3-word characters. I don't know. So assertions are zero width, right? So they will look ahead and do something like that, or they will look ahead and make sure that something like that doesn't happen. And we will get to the point where we do look behinds, but we have to do several other things before we get there. So for now, we just need to figure out what to do about assertions. Now, the thing that's funny about them is that there are some complications, right? There's a wrinkle that arises. I can say, look ahead, and let's say I matched, I don't know, some characters here, no one cares, and then only match if I look ahead and see the string ABC. That's all great. But what if I put something in here like B or capital B, I don't know, something like that. What if I put a capture group inside the assertion? What will happen is this, this is a perfectly valid capture group. It's just that the whole thing will not actually consume those characters if this does in fact match. However, this capture group will contain the value that was embedded in the assertion. So when we're matching forward, we actually have to do a couple things. One, we have to keep track of where we started so we can reset our offset. That's going to move around because if this works out, then the offset will have changed. But we also need to keep track of new capture groups that have arisen as part of this assertion. And we need to keep track of them because if this all works out and then we have more regex over here, if this fails somewhere over here and we start backtracking, when we get to this assertion, I need to, I don't actually have to move back any characters, right? This assertion should be zero width, but I now have to go remove this group that I've captured here. And so to achieve that, this is where the key comes in. So in order to get around this, I need to know if this key has been added as part of my assertion, and then if I get backtracked into, I need to go remove any groups that have been captured from the stack of group info, right, that we already have. So before we do the new item, we need to move back to our context and add some features. Okay, so let me try and find it. Handle the key parameter here. So when we push a new capture group, quote, onto the appropriate stack here, what I'm going to do is I'm going to keep track of a key that just forever increases by 1. So let me first do the following. So I don't remember what the snippet is. Prop full with a backing field. Yeah. All right. So this is going to be int little key, and the public property is going to be capital K key, and I guess I'm happy with that. Now this is always going to be just mapped to key, so this works perfectly fine. But every time I push something on, I'm going to increment key and use that as the new key. So what's going to happen is this number is just monotonic increasing forever and ever and ever. As soon as I capture something, it's going to be given a larger number than any other capture group information that I've gotten so far. So what I'm going to do in order to make the backtracking work for these assertions is I'm going to take a snapshot of the biggest key that I've used so far, and I'm going to save it onto the stack as part of my backtracking info. I guess I'm just saying that, but if it's not obvious, this stack right here is the guy that stores my backtracking information, whatever it represents, right? In this case, one of the things I'm going to store is the biggest key that's been used before I even get into this. That way, when I backtrack, I can just remove any capture group info, capture info items, I don't know what to say, that has a key larger than that, and that will restore each capture stack for each capture group back to its original state. So I'm going to need another function. So we got push peek pop here, and there's our key, and this is going to be for storing backtracking info regarding capture groups. As a little note to myself. And let's slot something in here. So internal void, and we'll call it restore capture stacks int key. All right. And what I want to do is go through each guy in capture stack keys, right? So for each int, I don't even know, int group in capture stack.keys, I want to go through here and say while peek at group, really maybe I should make that group ID, dot key is greater than, the parameter key, then I want to pop this group off the stack, right? And so I will rename this to group ID. That's a little more clear. So I'm going to go through each group, each individual group ID, and then while the key that is at the tail end of the stack is bigger than the key that I want to restore it to, I'm just going to pop that guy off. And so this will truncate all of the stacks with the capture info back to where they should be. So that is the plan there. Okay, now what else am I going to need for assertions? Well, the other thing, so this is the wrinkle here, but that's solvable, right? We just figured out how to deal with that. The only other thing I need to do is any backtracking info that happened while this assertion was being executed is completely irrelevant. And that is, so for example, this is actually a good example of assertion. I'm kind of happy I made this. So there's going to be two pieces here that I care about. There's going to be the capture info, which I'm going to make note of the keys so I can restore this if I need to. And there's this alternation within it, which is either going to match a little b or a capital B. When one of those matches, assuming it does, it will push the backtracking info, which is which token it matched in its list, onto the stack. Now the assertion is a zero width assertion, and there's no backtracking into it, right? It's not like I backtrack into my assertion and start testing other things. I just flat out reset back to where we were because it's zero width. So when we start matching, we're also going to take a snapshot of how big the stack is at this point. And if we completely match the stack, then we're going to pop all of the values back off the stack until it's the appropriate length. And that will restore all of the appropriate state back to the context, with the notable exception of retaining the actual capture info. When we backtrack, we will simply pop the, we will call this restore capture stacks, which will deal with this, and the stack info for backtracking that is part of the tokens inside it will already be gone. Okay, so that's the plan. So the other thing obviously we're going to need is to keep track of stack size. So we'll need a way to get at it, right? And I think I made this thing private. Push pop. So why don't we just say public int stack size maps to stack dot, what is it, count? Count or length? Never sure. All right, stack to the count. So that's the guy I'm going to need. All right, so now that we've sort of put some of this framework in place, let's go and actually add our new class. And this guy is going to be called assert. This assertion is going to be for something. We're going to simply assert a single token, and that's going to come into my assertion. So this is going to be a subclass of match, where'd it go? Match single base. And I'm going to go ahead and implement that. And I'm going to generate a constructor. And we're going to keep track of one more piece of information here, which is whether or not this is a positive or a negative assertion, right? Because I can say a positive assertion, something like this, or I can say a negative assertion, and it would be something like that, right? And these are going to be lookaheads here. So, I just realized I need to do one other thing. So I exposed, blah, blah, blah. I exposed this stack size here. I'm going to go ahead and make a helper method that's essentially this, but for just restoring the stack. So I guess I'll slot it in right here, and I'll say public void restore stack int stack size. And this is going to be, very similar. It's going to be while stack dot count is greater than the stack size parameter. We're going to say pop, right? Which I guess I may even be able to just cut this straight out into something like this. So you can let me do that? No, it's worth a shot. Okay, and so that's it. We're just going to pop those guys off. Okay, so I'm going to need that. Now, let's flip back to the assertion, and first of all, make a public read-only bool positive, and I will set that in here like so. Okay, so this video is already getting a little long, 12 minutes, so I'm going to go lop this off here, and we will implement the actual matching behavior for the assertion in the next video.